Yeah, I'm lucky I have like dress clothes today. I can't find anything in my house right now.
Where are you moving?
So moved to Ventura, moved out in the country. So,
Oh, really?
yeah, so moved houses started Friday night and didn't get done till Sunday last night. And we're still not done. We still have to move all the kitchen stuff still. So yeah, it was everywhere. You don't have internet yet, so it's like a disaster right now. So yeah, my OCD when I walk in the house just goes off like crazy because I like it organized and nothing's organized.
How did you decide to move out to the country?
It was a farmhouse. My mother passed away, so we're moving. So yeah, moving out to the farm. So it was in the will a long time, and we kind of knew, but it was due by like September or something. So we had to do it for taxes coming up September 15th. So yeah, it's kind of stressful right now. So, but let's get going to a couple problems. We're doing laws of exponents today. So we're still in section 2. We started this on Friday. So today we're just going to kind of practice. So the section is P.2. It's prerequisites section 2, and we're just doing the laws of exponents. This is something that you did in algebra 2 a lot. Maybe if you're lucky enough, you saw in algebra 1. If you're lucky, some people do. Depends on what section of algebra 1 you were in. But yeah, this is kind of like the main staple of what all of algebra 2 is, and I'm trying to cram it into like a 2-day like mini review. So it's like one of those things like we just need to see it. There's certain things that we'll cover. Some stuff is easy, like you remember really well, and then there's some stuff that's like, yeah, I didn't know you could even do that. That was kind of a shortcut. And I've been trying to show you different methods of doing the same problem. Because sometimes you get stuck. You're like, God, I don't remember the rule, right? I don't remember, am I supposed to add or subtract? Am I supposed to multiply these powers together? That's why I'm trying to show you multiple avenues of how to approach a problem. So if you don't know, I'm going to go through a couple problems that we did on Friday. We did the product rule on Friday. So I'll just put this problem on the board. And so Courtney, this would be one I want on your little like sheet of paper. So you can put your notes, but I'll just put it on a sheet of paper. So the product rule was, and I'll just give you an example here, was when you take certain items like this, and you multiply them on items that have similar letters. Right? Doesn't matter if they have matching letters. They can have extra letters for all I care. Like a Z. And you can multiply them together. That's called a product rule. You're multiplying items that have variables on them with exponents. Okay, what was the general rule that we talked about? So who can kind of fill us in? What was the rule that we discussed? Shortcut, even. What do you got?
Add the exponents.
Yeah, you add the exponents, right? So the two numbers out front, you multiply like normal. So 3 times 5, what do we get? 15, okay, so that's normal, right? Because you are just doing multiply overall. But then for the exponents, like Annie was saying, you just add them. So if I added the x's, how many total x's do I have? 5 of them, right? How many total y's? 8, because you have 1 and 7. And then obviously you have that z in the back. And if you want to put a 1 on the z, you can. You don't need to. It's assumed it's a 1 anyway. And that's the answer, right? That's what we're looking for. We did what? A couple of those on Friday? I think I had you try one. We did one, so get that on your paper. That's what we did. That was the practice problem, right? Make sense? Okay, that was one of the big rules. That's like, if I can think about like the laws of exponents, that rule is massive because it's used in almost everything, especially when we go to the second rule, which was the power rule. Right? Power rule. So let's say that my problem, again, this is an example, and this is one that Courtney, I'll have you write down in a little piece of paper as well. Power rule is when you have something in a parenthesis and you put a power on it, on the parenthesis itself. So let's go with like 4x squared y to the 5th, and we're all going to square this. We're going to put power of 2, right, square. Now there's a couple different ways you can do it, but does somebody have a shortcut we could talk about? How do we do it? So volunteer if you want, please.
Wait, do you distribute?
Yes.
The exponent?
Yep, you distribute the exponent, right? So you're going to take that 2, and you're going to literally just put it on everything. It's going to go on the power, okay? So I agree with that. That's step 1, right? You got to distribute the power. That's a part of the shortcut, right? Now, what do we do with it once you distribute it? What do we do? What's the rule? Does it add, subtract, multiply, divide on the power? What?
Multiply the exponents.
Yeah, you multiply the exponents, right? So right now on the 4, the exponent, the power on the 4 is a 1. We have to multiply. The 1 and the 2 get multiplied, so it's 4 squared, right? Because you have to multiply that 2 on the power that's sitting there. For the x's, how many do we have? 4, right? Because you're multiplying the 2 and the 2 together. And then for the y's, 10, right? Because you're multiplying the 5 and 2. That's the answer. Now, we have one more step, because you can go 4 squared, right? 4 to the power of 2 is 16. And this would be the final answer. Make sense? That was one of the major rules. Now, I did show you a different way of attempting that problem. Right? That was something that we talked about on Friday. It was like, you don't have to do that rule. Maybe that rule confused you. Like, how do you know you're supposed to add versus multiply, right? Add versus multiply the problem. You add them when you're multiplying these two things together. When you distribute, distribution is always multiplying. No matter how you think of distribution. Right? Think of algebra 1 facts. Right? When we did algebra 1 back in, early freshman year, maybe 8th grade year, or 7th grade year, if you're lucky enough. When we did a problem like that, that required distribution, you always multiply. No matter what, you're multiplying the 2 on everything. Well, that's what you do here. You are multiplying. That's just a different way of thinking of it. Now, the other way we attempted this problem on Friday was just writing 2 of the bases. You had 2 of these being multiplied together. This is exactly what this thing means. You have 2 of the bases. And that's why this rule is important, because it really used that rule. You add the exponents in the long run, unless you know the shortcuts. All right, questions. I know I talk a lot. Sometimes it's just nice if you have a question, if you'd like to see a certain type of problem. Okay. Now, the last problem that I think we did get one. We did a fraction rule, correct?
Yeah.
A quotient rule? Okay. I didn't know if we got to one. So Courtney, this would be the last one you have to write on your paper, okay, for that little slip. Okay? All right, so let's do a quotient rule. Okay, so a quotient rule. This is where you're dividing items, right? It doesn't matter what the items are, you're going to attempt to divide them. So, for instance, this will be my example. Let's say it's like 3x squared z to the 4th all over 15 x to the 7th yz. You're going to just simplify these. So there's rules that they teach you in algebra that you can subtract the powers and all that. You take top minus 5. That's fine. When I do this problem, I think of it as just canceling. Things that match cancel each other out. And you're just going down to the minimum of what your answer should be. So, for the 3 and 15, what can I do with those?
Divide.
Divide them both by what?
3.
Right? They both have 3's in common. So divide them both by 3. Right? So if we divide 3 by 3, we get what? 1. If you divide 15 by 3, you get 5. So divide both numbers by 3's. Perfect. If they have it in common. Right? If they had 2's in common, divide them by 2's. Always pick prime numbers. 2's, 3's, 5's, 7's, 11's, 13's. Just pick numbers that are small and then eventually work your way up until you find something that they have in common. If they don't have anything in common, leave the 2 numbers. Right? Maybe there's nothing in common. Now, for x's, the rule that I talked about was just get rid of the smaller of the 2. So you have 2 on the top, 7 on the bottom. Get rid of 2, because that's your smaller number of x's. So I'm going to cross these out. And then you have to get rid of 2 off the bottom as well. So you're going to have 5 x's on the bottom. That was my little shortcut. Now there is proper ways to do that. I'm just showing you my shortcut. Right? You can just cancel them out. It's cancel rule. What about the y's? Do I cancel any of those out? No, there's only one of them, so I'm just going to leave it. Nothing I can do with that. If you want to put a little 1 on it, you can. If you want to just leave it blank, I'm fine with that. Doesn't matter. What about the z's? What happens to that?
What did you do for Z3 or
Z cubed on the top? Yeah, Z to the third power, Z cubed, if you will. Because you're getting rid of one of them off the bottom, right? And so you have to get rid of one of those off the top. These cancel. And that's your answer. Now, the proper way we heard it, I don't know who volunteered it Friday, but they said that you take the top power and you always subtract the bottom power, no matter what. That is the correct rule. Okay, that's actually the proper definition of what all textbooks tell you to do. You take the top power minus the bottom power, whatever it is, then you leave it there, right? So let me go back to this problem. Right, 5 x to the 7th x squared, right? I'm just going to stop here. What you always do is you always take the top minus the bottom in terms of powers, if they have a letter that matches. And so, and when you do that, it will tell you what your final answer should be. So for x is 2 minus 7, this ends up being x to the -5th, right? And then, yeah, this is the new rule that I want to talk about today. And you're absolutely right. If it's a negative power, a negative exponent, it's on the wrong side of the fraction bar. It's a division rule. You have to move it to the other side of the bar. So if the negative is on the top, for a power, it has to be a power, by the way. If the negative power is on the top, it has to move to the bottom. So this would be x to the 5th going down here. And it'll be going off the top. It's just telling you it's on the wrong side of the fraction bar. It's like a notational thing. So you have to move the x to the 5th from the bottom, which is exactly what happened here. That's all a negative exponent is. It just tells you, move it. But that was the proper rule. I heard it Friday, I don't know who did it. It was really well said. So. All right, but we'll get to this. This is going to be a big one today. We're going to come back to this one, this idea of a negative exponent. Now, again, is there any questions on the problems that we did from Friday? I'll make sure everyone's comfortable. I know I take it kind of slow, sometimes it's stupid, but I think it's important. It's nice to see a review sometimes, how to do some stuff. Especially, it's been a long time, it's been 6 months. You probably forgot some stuff. Okay. Any questions at all? Let's get to some new stuff today. Courtney, I'll take a little piece of paper. You get some place for that. Pretty easy. Pretty straightforward today. So, all right. Okay. The things I want to cover today. Negative exponent rule. I want to talk about that today. I want to talk about the zero exponent today. So if you put a 0 on something. And I want to talk about what happens when you start kind of mixing them all together. So like if I were to have, a power rule with negatives, with fractions in it, like how would we attempt massive problems that have powers and things going everywhere, and different attempts at how to simplify it. Because that's all this is, simplifying. That's what I want to do today. And then tomorrow we'll get to the assignment tomorrow. Something, I'm going to keep it relatively small. I consider like that page 15 to be a bigger assignment. There's just a lot of problems there. I'm just going to keep it kind of basic stuff to show me that you know what you're doing. You get a couple practice problems of each type, but I don't want to pick, I don't know if that was like, 18 problems, something like that. To me, that's kind of a bigger assignment for you guys, especially when we get to the more challenging stuff later coming up in the next couple sections. All right, let's jump right in. Let's talk about the rules for negatives and zeros, because I'm gonna show you the way that I learned it, and some people have never been taught this, and I think it's kind of a shame. So, okay, so we're gonna get into negative exponents and zero exponent. But I want to start with something that you can wrap your head around, and then we're gonna tie it all together. Okay, let's start with the basics here. Let's go with, I'll just pick an easy number. Let's say like 3. I'll start with this. These are 4 different examples. Okay, and then I'll hopefully tie stuff together with this. All right. What's 3 to the first power mean? Like, what's the answer?
It's just 3.
Just 3. Now, why? Let's talk about that. What's the meaning of like having an exponent of 1?
2. Just 3.
Yeah, just 3. Because how many of the bases should you have? 1. Does that make sense? You have 1 base. So what is 3 squared? 3 to the second power.
You have two bases, so it's 3 times 3.
Yeah, absolutely right. That's exactly what it means, right? 3 times 3, which is 9, right? 3 times 3. So, okay, 3 to the third power.
E times C times C.
Good, okay? You have 3 of the bases, right? The base just happens to be a 3. You have 3 of them, and it ends up being 27. And the last one.
3 times C times C times C.
Yeah, just 4 3s, right? So not real hard. Again, there is a rhyme or reason to why I'm doing this. I know this seems silly. I'm not trying to have you memorize the 3s. That's not real smart. But let's talk about why am I doing this. Every time you go and add another power, so you add another exponent, you go from 3 to the first to 3 to the second. You're putting another 3 on the problem. You're taking the previous answer and multiplying it by 3. Right? Because you just added another 3, right? So the next one, I would multiply by 3 again, because you added another 3 to the previous problem. Previous problem was 9, you multiplied by another 3 and it became 27. 9 times 3 is 27. And then you multiply by another 3 again. 27 times 3 is 81. Does that make sense? Every time you moved up a rung, it just added another base number. Or multiplied another base, maybe that's a better way to put it. Now, with that same logic in your head, as we move backwards, I'm getting rid of a 3. Right? I'm getting rid of a 3 as I move up, so I'm going to reverse the ladder. So if I went up the ladder, instead of going down, get rid of the number, you divide by 3. 81 divided by 3 is 27. If I went up the rung, went 3 squared, you divide the previous one by 3. 27 divided by 3 is 9. If I went up the rung, I divide by 3 again. So 3 squared was 9. I divide 9 by 3, I get 3. Right? What happens if I go 3 to the 0?
0.
1.
1. Because what's the rule when you go up the ladder?
Right.
You divide by the base number. So every time I went up the rung, it divided. And so 3, that was in my previous answer, I divide it by 3 and I get 1. I don't know if you've ever been taught that. That's the reason why anytime you put something to the 0 power, it always ends up being a 1. Every single time. It's because of that rule you're watching right in front of you. As you move down the rungs, you multiply. As you move up the rungs, you divide. And now here's the crazy part. My rule that I'm showing you here, and this is my rule that I have been taught from my previous math teacher, keeps working every single time. So if I went to 3 to the negative 1, right? I moved up a power again, right? I'm going this direction again. What do I have to do again?
Right.
Divide. What was my previous answer? It was a 1. I have to divide it by 3. That totally explains why the 3 goes to the bottom of the fraction. Because you're dividing by it. Because you went to the previous answer and divided by 3. Divide by 3 means you put it on the bottom of a fraction. Now, if I went to 3 to the negative second, what would you do again? Divide by 3. So you'd put another 3 on the bottom of the fraction, which ends up being 9 on the bottom. This is the reason why things work. Now, if you don't understand that, it's like, or you're taking 1/3 and dividing by 3. Yeah. Because this is a rule you probably should have learned in Algebra 2 or Algebra 1, that when you divide, you can change that to multiplication, and you do a reciprocal. So when you multiply fractions, you go straight across. That's why it's 1/9. But the trick is just add another 3 to the bottom. That's how you divide. This is the reason why everything works out, why things are on the bottom of fractions and why they're on the wrong side. It's because of this rule of multiplying versus dividing. Again, this is the way my math teacher taught me, and it makes sense. It explains why things end up being on the bottom. And it's just, sometimes people never get to see that, and I think it's a shame. Because it does explain the rules and why things work. Especially like this power of 0. It's really hard to explain it unless you see this. Then it makes total sense why things are working. All right, questions with that? Okay, let's get to the real, the real stuff that I want to talk about. So let's get to the actual example. This is just kind of to clarify some things. Let's get to the negative exponent rule. The negative exponent. So we've already talked about, we've even discussed it earlier with that first problem, when you have a negative exponent problem. So I'm just going to give you kind of a bigger problem. We're going to kind of move some stuff around. Do that. So just kind of picking a big problem, just throwing some negative powers in there. So again, I'll read off the top. I know you're still writing. We have -2, x to the 5th, y to the -3rd, z to the 4th. That's all along the top. Along the bottom, we have a 7, an x squared, x to the power 2, y to the -6th, and z to the -6th. Yes. Yes, sir. All right. Now, let's discuss negative exponent. I've even hinted at it earlier. It means you're on the wrong side of the fraction bar, right? So you're on the wrong side. So anything that has a negative exponent is going to move. It's going to switch sides. I always like to take care of the negative exponents first. I like to move them. It makes things a lot easier to look at. It makes everything nice and pretty. Then you can start to simplify it. Don't simplify it first. You can, I just don't recommend it. There's different ways to avoid it and to get the right answers. And I'll come back to the way that somebody said it on Friday. Okay? All right. So when we look at this problem, what items need to move? Let's just discuss that.
The y's and the -6, or z to the -6.
Yeah, the y's, both y's, and that z. Does everyone make sense of that? The 2 doesn't move. The -2. Why does that not move?
It's not a power.
Nailed it. It's not a power, right? I'll get somebody with it. I know one person will fall for it, especially when you get in the homework. I always get one person that moves that to the bottom, makes it a +2. No. Only the negative exponents move. Everything else will stay. So let's do that first. So on your problem, maybe on your notebook, let's move all the things that have negative exponents to the other side of the fraction, and when you move them, you make them positive. So let's do that first. So I'll give you a little bit of time here, start moving things around. I'll even do it myself. -7, x squared, y to the 3rd. All right. I'll stop here. Trick is to remember what moved, what didn't. So if you notice how I did mine, I did all the top row, and I wrote down all the bottom row, so I can figure out, okay, what was moving, what stayed, that type of thing. I try to keep track in my head. Okay, now, I think most people can handle that, right? You move stuff around, you make it positive. Cool. Now what?
Would you try and simplify the z's together?
Yeah, so the z's have to combine. How many z's am I going to have? 10. So let's do that. So the z, we're going to have 10 of those, and those are going to be in the back. All right, now somebody else. What else do we do next? What's another thing we can do? Please.
Subtract y to the 6 from y to the 3rd.
Yeah, you need to get rid of the y's, right? There's too many. There's y's on the top and the bottom. So I'm going to do that little cancel rule. So I'm going to take away the smaller one. So I'll take away the 3 here, and I'll take away 3 from the top. So that means I'm going to have 3 left on the top, right? Because there was 3 on the bottom, there was 6 on the top. I subtract 3 from both. Okay, did that make sense for the y's? Somebody else now. Thank you for those two. Somebody else. What do we do next? Please.
Do you put 2 on the x with 5?
Yeah, the x squared, right? We're going to take that from the 5. So how many x's are we going to have?
3.
3, and we're gonna have them on the top. Right, because there's more of them on the top, so they have to stay there. There's 3 left after I took away 2 from both top and bottom. What about the -2 and the 7? Anything I can do there? Nah, let's just leave. There's nothing, they don't even have anything in common other than a 1. That's your answer. That's it. That's the shortcuts. Right, that's doing everything at once. That's moving all the negative exponents. That's doing the rule for cancellations. It's kind of doing everything we need. If that made sense to you, you're more than fine for the stuff I'm going to assign to you. That one had a lot of variables. Some of the stuff, the problems I assigned, there's only 1 or 2 things moving, not like 3 or 4 things.
Would this be one of the harder problems on the homework?
Yeah, that I consider it one of the more challenging ones. I know you're thinking, well, that's easy. Perfect, great. You're already kind of in there, and maybe you already remember stuff. Now, I'm going to throw a couple of problems on the board because to me, that isn't pre-calc level yet. It's not even close. So I'm going to throw a couple challenge problems on the questions here, just on the marker board, to get you really thinking about some more challenging ones. So Gurney just missed, so we just kind of finished that up there. So you just kind of see that problem. We moved some stuff around and simplified it. So. All right, so I'm going to do another one of these, and this is what I want to focus on today. I want to do maybe 1 or 2 more of these, but I want to mix everything together. I'm talking fractions, negative exponents, powers. I'm going to throw it all at you. I want to see kind of what we can do here. So I'm going to put a problem on the board. I'm going to give you a few minutes to kind of work on it, see what you have, and then we're going to go through it all together, and I'll ask for volunteers, new volunteers. Again, thank you for all those who are volunteering. But I'll ask for some new volunteers to see how we can do it. All right. So the example I want to start with, put it here. This will spill over probably to my other board so we can see it. Let's go with 4x to the -2, y to the 3rd over 12x to the 4th, z to the 9th, all to the -2nd. So I'll give you a few minutes. You can try these out. If you don't know, it's fine. We're going to go over it together. It's kind of nice to try a problem out, see if there's certain things you got right, certain things you need to work on. Look at this one last. Can you guys see that? Or is there a nasty glare in the cord over there? Can you see that run? Okay. Okay. I always forget. You guys have like the worst ink on the board. Give me another 2 minutes, let's say. maybe another minute? Another minute here if you need it. Maybe you're stuck, maybe you're just kind of stopped. I can definitely tell you, if you're doing it a certain way, a calculator comes in really handy. Especially if you're trying to simplify some pretty big numbers. If you're doing it a certain way, anyway. We're going to go through this, and I want to get this answered before we're done. This might be my last problem of the day. Now, before we start, I want to know how you attempted it, because I can see a bunch of different ways to attempt this problem. I want to know how you guys attempted it. So, anyone volunteer? Okay, so what's one way you attempted it? Like, how did you start the problem?
I distributed the -2 to everything.
Okay, stop there. Did you do it differently?
No.
Okay. Did anyone else do it differently than just distributing the -2 to everything first? Oh, interesting. Everyone distributed the 2. Okay. In years past, I've seen people simplify it first, like in the inside, where they do the parentheses first. They simplify everything, then they distribute the -2. Seen that? It works. It's the same answer. In fact, your numbers would be smaller if you did it that way. I've seen years past where this is big. This is going kind of beyond what you probably want. I've seen people attempt to take this problem and they make this a fraction, right? They made it a fraction. And then since this is a negative exponent, they move it to the bottom of the fraction. So they make it this, like that. Then they start moving things around. That's big. That's taking it pretty seriously. It works. You just have to know the rules for reciprocals, because you'd have a complex fraction, fractions over fractions, that type of thing. I think I'm going to stick with what you guys did. I'm going to stick with that so we can kind of check and see how you did it, if everyone distributed the -2. So if I distribute the -2 to everything, let's kind of work on that. So you should get 4 to the -2, x to the +4, because -2 times -2, y to the -6, because you're going to multiply the exponents on. The -2 goes to the bottom, so 12 to the -2, x to the -8, and z to the -18. That's a terrible 8. Did I do anything wrong? That makes sense? Yeah, I don't think I got any of my math wrong there. Okay, now next step. Somebody else now. Thanks for some volunteers. Because I'm assuming everyone did this, right? What was the next step maybe somebody did after this? Because I'm betting you started here, right? What was the next step somebody did? Oh, yeah. Too shy. Too early in the morning. What do we got? I'll take anybody. What? Yeah.
All right. So is how I started.
Yeah.
I just simplified the normal numbers, not the powers.
Oh, okay. So you had that.
Negative
A 16th to the -1st and 144 to the -1st.
Yeah.
Yeah. Okay, you did that one. He's talking about squaring the 4 and squaring the 12th, making it a big number, and then it still has a negative exponent. Okay, that's fine. You can do that. Anyone else do it differently? I'll stick with that. I'm going to move them first. That's what I would do. I would have moved all the negative exponents after I distributed the -2. So I would move like the y to the bottom, the z to the top, this x to the top, the 4 down, the 12 up. I like to just have all the exponents positive. What is up with this marker? I'd like to have all the exponents being positive, and when you move them to the other side of the fraction mark, they become positive. They're on the right side. X to the 8th, z to the 18th, and that y to the 6th goes down. That's what I would have done. That's my personal preference. Is it wrong? No. Maybe it's different than what you did. It's fine. Some of you just like do shortcuts so fast in your head that you're skipping these steps. It's fine. Maybe you got to the final answer. How many x's do I have on the top?
12.
12. So there should be 12 x's on the top. There should be 18 z's on the top, and there should be 6 y's on the bottom. Those are going nowhere. There's nothing to cancel there. There's no other x's top or bottom, or y's top and bottom, or z's. So those are done. What we have to figure out is the numbers. The 144 and the 16. Because 12 squared is a 144, and that 4 squared is a 16. Those have to simplify. You have to simplify those. Okay, we'll come back, we'll look at this one tomorrow. Tomorrow, bring a textbook or your online version if you're using that still.
We set those up yet, haven't we?
What?
How many set those up?
The web link that I have on there, it just takes you right to the book. There's no login. Just opens it up. So, shouldn't have had that on camera.